In our eighth question, we want the equation of a line which is parallel to this given line. So let's first plot the line that is given. Let's plot this line. If you look at that line, it is 3x minus 4y is equal to minus 5, which gives us x by minus 5 by 3 plus y by 5 by 4 is equal to 1. So the x-intercept and y-intercepts can be marked out as 1.6s. So if this take this to be 1 and this to be 2, so this is minus 1 roughly, and this is minus 2 roughly. So yeah, this might be our intercept, which is minus 5 by 3 comma 0, and our y-intercept, again, if we take this to be 1 and this to be 2, 1.25 is somewhere likely here, so this is probably our y-intercept 0 comma 5 by 4. As you can see, we are doing a thoroughly rough plotting. We don't always have to be very accurate with our plotting. This is only for an indication. So this would be our line 3x minus 4y plus 5 is equal to 0. And now we have another line given to us, which is 3x minus 4y is equal to 0. Clearly, these two lines are parallel to each other because they have the same slope. And that slope would be, we write it as y is equal to, we'll get 3x by 4. So the slope is 3 by 4. And it is passing through the origin, because if I put x is equal to 0 and y is equal to 0, the line equation is satisfied. That is, there is no constant term. So this line is our 3x minus 4y is equal to 0. And we are trying to find a line that is parallel to these two, and it is at a distance of 1 unit from the 3x minus 4y plus 5 is equal to 0 line. Let's name these lines as well. Let's call this L1 and this is L2. I am going to erase the intercepts to make it look a little cleaner. And now we can find our equation, and for that we will use the formula of separation between two parallel lines. So if there are two parallel lines and we write them with the same coefficients, so ax plus by plus c1 is equal to 0, and the other one would be ax plus by plus c2 is equal to 0. This is how two parallel lines would look like. You can reduce them to have the same coefficients for x and y, like in this case. So this is 3 and this is minus 4. This is also 3 and this is also minus 4. In this case, the separation between these two parallel lines would be c1 minus c2, the modulus, divided by root of a square plus b square. So the equation we are looking for, the line we are looking for also is going to be some 3x minus 4y plus c is equal to 0. So its separation from our L1 is going to be, applying the formula, modulus of c minus 5 divided by root of 3 square plus 4 square. 3 square plus 4 square is 25. Therefore, you have modulus of c minus 5 divided by 5, which is what is expected to be 1 unit. That gives us modulus of c minus 5 is equal to 5. Now, the modulus indicates that there are two possible values here. One could be c minus 5 if c is greater than 5, greater than or equal to 5, because then c minus 5 would be positive. And the other would be 5 minus c if c is less than 5. So what we get is two separate solutions. One is c minus 5 is equal to 5, or 5 minus c is equal to 5, in which case we get c is 10 or 0. So we have two lines. One is 3x minus 4y plus 10 is equal to 0. The other is our 3x minus 4y is equal to 0. This is our line. So now, because of this, we can say that this length between the separation between these two lines is now 1 unit. And therefore, the other line, which is our 3x minus 4y plus 10 is equal to 0, is going to come on the other side of L1, which is going to look like this. So this line is our L3, and it will have intercepts equal to, this should be 0 comma 10 by 4, which is 2.5, and this would be minus 10 by 3 comma 0. This is our other line. And now we should also find out what the value of A is, because A would be the distance between the lines L2 and L3. That is what they are saying, is A units away from our L2. And we know that this is 1 unit and this is also 1 unit. So this total length is going to be 2 units. So A is equal to